Find the volume of the solid in which the base is a circle of radius 3 units whose cross sections are described. We want the cross sections perpendicular to the x-axis of square. Right. So I'm going to graph a circle with radius 3 right here. This is the bottom part. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I'm going to try to make this a circle. So I'm going to do the best circle. All right, so we got this deal here. Well, you are supposed to know that a circle is x squared plus y squared plus 3 or equals 3 squared, which is 9. Okay, that's the equation of this base right here. And we're going to have perpendicular to the x-axis. So what that means is my rectangles are going vertical like this. So this is a dx problem because the width of my rectangles is going with the x-axis. So we all understand how the little rectangle can help you know dy dx. The other one is dy. This is dx. So I am supposed to solve this thing for y. So that would be the equation when you solve that for y. Because I have everything in terms of x. Okay, so I'm going to have this thing, this top to bottom rectangle, this is my bottom of the square. So if you can imagine a square coming out at us off the screen, the same length as this top minus this bottom coming out towards us, and then back down here, and then back to the screen. That's what my squares look like. You understand what I'm saying? So if I took this paper, if this was the paper and I had a circle drawn on this paper, the squares are coming out at me like that, like this other paper. Do you understand what that's supposed to look like? Now we're supposed to know that the area of a square is side squared. That's the area. You should know that. And so this thing right here, from this top part to this bottom part, this thing right here is that S. Top minus bottom is the S that's there part of the square. So the S is going to be the top part of the circle. The top part of the circle minus the bottom part of the circle. So the top part of the circle is above the x-axis, so that's where this thing is positive. So that means the top part is the square root of 9 minus x squared. And then minus the bottom part's underneath the x-axis. That's the negative part, so it's minus a negative square root of 9 minus x squared. Top minus bottom function. You see where that comes from? And so you got minus a negative, which changes to plus a positive. So this is equal to 2 square root of 9 minus x squared. There's my S. You good with that? Okay, so the volume of this thing full of squares is going from the left x value to the right x value of my S, which is this thing down here, squared dx. Now, if I did that right there, that would give me my answer. Okay, and I think I did it this way on the notes. Then I said there's a shortcut, and here's why. Isn't this circle symmetric to the y-axis? Yeah. Right? So another way to do this same volume problem, which is what I think the question was asking me, was, I said I could do the integral of 0 to 3 of 2 times 9 minus x squared dx. Now, how much would this be of the circle if I started here with my rectangles? And I went rectangles all the way over here to the right. I said rectangles, I should have said squares. If I put all these squares going over here to the right, how much of the volume would that be? That'd be half, wouldn't it? Because I'm only going from 0 to 3. So what you can do is, if you have symmetric to whatever direction you're going, you can say, hey, this is half of it, and I can double that to equal the same thing as this thing at the top. Now, why is that a good thing to do? Does anybody know why? Anybody give me a guess why this is a good thing to do? It will save me time. That's right. When I do this one, when I do the integral of this, and by the way, you would square this first. I hope you all know, and get 4 times 9 minus x squared when you squared that, right? I hope I did it this way. I don't remember what I did on the notes, because I always try to hurry them too much, probably. I hope I did this and then did the integral. It's faster. So when I plug in, when I go back over here and I plug in a 3 and then a 0, do you see how zeros are really good numbers to plug in? They make the math way faster, right? So that's why you would want to save you time. It would save you time if you take half of the volume and then put a 2 out there, because it's actually doubling that. Your thumbs up. What does that help you understand what's going on? Okay. Anybody else got something? Yeah.
I'm kind of jumping back to 8.9 page 12. When you do the x-axis or y-axis, when it spins around the x-axis or y-axis, will you always be using the disk method, or will there be times where you're using the Washer method?
Okay. Well, let's go to that. Let's go to that problem I just did a second ago, right? What method was this?
The Washer method.
This is washer because there's a hole in the middle, right? Now, if there wouldn't have been a hole here, if they'd have said rotated about the line x equals 1 instead of 2, and I did it all around, this was the line I was rotating around, would there be any gaps? So that would be that would not be washer, that would be disk. So the answer to your question is it could be either, I think, right? Yeah, it depends. It depends on if you got space between non-shaded part between what you're rotating it around, or shaded part. If there's an open part that's not shaded, then it's washer. If there's no open part, then it is disk. You guys understand what I'm saying? Yeah. Okay. Anybody got a question on it? If you're not sure, look, thumbs up if you understand. McGee, you there? Hey, does this mean you're not sure?
Yeah, I'm just.
Talk to me. Talk to me. Let me straighten it up. I'm gonna pause the video while you're pondering.